The Cliff Lab. Our task here is to predict where the ball will land when it rolls off a cliff. It comes in 3 parts. The first part, we have to find the velocity of the ball. The second step, we're going to find the time in the air. And then the third step, we're going to actually predict the landing spot. Step number 1, put the ramp in a position on the counters or on the floor so that the ball will roll 1.8 meters. Now that is not counting the ramp, and it's just the horizontal distance. So here I have the ramp, and I'm putting it on the counter at the seam between the peninsula and the side counter. And that seam right here is going to be 180 centimeters to the end of the table. Step number 2, start the ball rolling from the very top of the ramp. And then step 3, time how long it takes to roll 1.8 meters. So you're going to have a person release the ball from up here, but the timer does not start until the ball reaches the horizontal part, the start of the 180 centimeters. And then you're going to time it until it reaches the end of the table and stop the timer there. Step number 4. Repeat for a total of 10 trials. Record all your data. So we have the 10 blanks. Put a single line through any outliers, weird numbers that seem out of place. So your numbers should be fairly consistent. It's going to be roughly about 2 seconds. I'm not going to tell you how far away from 2 seconds, but roughly. So if you get something that's really weird, like 3 seconds or a half a second, you're going to just draw a single line through it. Don't scribble it out completely. Don't erase it. Don't ignore it on your stopwatch. Write it down, but you just are going to draw a line through it. Maybe later on we'll realize that there was something important going on, and that data is important for us to see. So anyway, find the average of the remaining consistent times. That's step 6. So maybe you crossed off 3 outliers. So you're going to find the average of the other 7. And you're going to write down the average time then right there. Step 7, find the average horizontal velocity of the ball. To find that, you're going to use the equation up here. Vx equals delta x over t. Your delta x is the 1.8 meters. You have to have it in the meter form. And then the t is your average of the good data times. So just divide that, and that'll be your v sub x, your average velocity in the horizontal direction. So you're going to work that all out here. Okay, that's the end of step 1. You found the initial velocity. Now you're going to do part 2, find the time in the air. We're going to be using the time to drop equation for that. So we need to know the h and the g. So we're going to measure the height of the cliff that you'll be using. This is located in the middle of the room. So we're going to go to the back here. And here is all the different heights that the different lab groups are going to use. So lab group 1, you're going to have your ramp way up here. And you're going to drop this whole distance to the tabletop. Lab 2, you're going to have a shorter distance, and so on all the way. Labs group 7, you're going to have the shortest distance for you to fall. So you're going to be measuring from this level down to the tabletop. That is going to be the h value. The g is 9.8. Now remember, your h value needs to be in meters because the 9.8 is meters per second squared. So use that equation now in this space to figure out how long it's going to be in the air. You better come up with something less than a second. Part 3 now, predict the landing location. Predict the range by using the equation. The delta x is the range. The v is the number that we figured out up here in part 1. And the t is the time that we just figured out in part 2. So just work that out here. You're just multiplying velocity times time. Your answer down there. And that will be in so many meters. You better come up with something less than 0.5. Now, In order to measure this out, number 12, place a long box perpendicular to the track at the predicted distance from the end of the ramp. So again, going back to the middle. If you said that it was going to drop off of this height here, let's just make up a number, 0.33 meters away. You're going to measure from the bottom of the box here, 0.33 meters. Move the decimal point over 2 places, so that's going to be 33 centimeters, which would be about like that. If you got an answer of a range of 0.12, that'd be 0.12 meters. You'd have to change that to be centimeters. That'd be 12 centimeters. Remember to move the decimal point over 2 places. So you put this long box in this orientation at whatever distance you want, and then you put your ramp. Oh, let's grab a ramp. Put the ramp on there like that, and test it out. See if it lands in the box or not. And that hit. Now the ball is going to roll at slightly different rates perhaps, and so if you can get it into the box once out of 3 attempts, we're going to call that a grand success. When you're done with the lab, please work on the 3 problems that are on the front side of the sheet and catch up on any homework that you might have. Good luck.